Hello, pre-cal babies. We are officially in Unit 6, and that means we're going to be talking about graphing trigonometric functions and their inverses. So we're starting this kind of like we did with our parent functions at the very beginning of the year. So we're going to talk about our trig parent functions, and then of course we're going to move away from talking about the parent function and then begin talking about how to transform them, etc., etc. So what we need to do, we need to first discuss why we need trigonometric functions, or what they are. They are periodic functions, and that just means that they return to the same value at regular intervals. So as you can see down here in my graph, that just means we continue on and on and on and on, okay? So that's what it means to be periodic. So and you'll notice this as we move through here, the cosine graph is very similar to the sine graph. So we refer to these periodic functions as sinusoids. So we talk about the sine function or any periodic function with similar properties. So even when we have a cosine function, we can still talk about it as a sinusoid because you'll see in a moment they look very, very similar. So as we're looking through here, you will notice that I have the graph for the sine function here, and then I've got all of the properties. So these parent functions are going to have properties listed just like we did for the quadratic function and the linear function and the cubic function, all of those. So as you'll notice by my graph here, I've only got part of the graph done because technically this goes on forever in both directions. And I also want you to notice that the x-axis is labeled in radians, but it can also be labeled in degrees. So the parent functions, all of these will be written in terms of radians. So when we look at our properties, you'll understand what that means. So as you'll notice here, all of the x values are covered. So we've got all real numbers. The range, we just go back and forth between -1 and 1. We cross the y axis at 0, 0, and then of course our x-intercepts are going to occur at intervals based on a whole value of pi, where that whole value is an integer. All right, and then at the period, that's how long it takes to make one full cycle. So that's going to take 2 pi, which is basically once around the unit circle, if you'll think about it in terms of that. And then, of course, we have symmetry about the origin. We're reflecting in quadrants 1 and 3. We have no asymptotes. Our extrema, those are just our high and low points. We're not going to deal with those very much. When I talk about oscillation, I mean it bounces back and forth between 1 and -1. So see, it bounces, okay, and it continues to do that for the length of the entire function. So this is an odd function because it has origin symmetry, and it's continuous because we can draw it without picking up our pencil. And of course, as we read it from left to right, it is both increasing and decreasing. Okay, now we're going to jump right in to the reciprocal function for the sine function, which is cosecant. Now, if you'll recall, along the unit circle, there are values for cosecant that are undefined because of that reciprocal idea. So therefore, our graph will have asymptotes, and it will look a little different than our sine function. So here are all our properties, and we're not going to spend a whole lot of time on the cosecant function because we're not going to transform these, but I did want you to see what it looked like. Okay, now we're going to scooch down and look at our cosine graph. And remember, I told you it looked very similar to the sine graph. The sine graph, of course, does this. So it's basically, the cosine function is basically the sine function just shifted. So if you can think about it that way, that will help you understand it a little better. Because it is shifted to the left, it's of course going to have a little bit different properties over here. The domain and the range stay the same, but the y-intercept changes, and also the intervals for your x-intercepts, because now they're occurring at half values instead of whole values. The period's the same. The symmetry is different because it's y-axis symmetry. There are no asymptotes. The min and the max, of course, occur at the high and low points. We are still oscillating between -1 and 1. This is now an even function because of the y-axis symmetry, still continuous, still increasing and decreasing from left to right. And of course, the secant graph is the reciprocal of cosine. And just like the secant graph or the cosecant graph looks weird, the secant graph also does because we have asymptotes and this idea of reciprocal. That's why you're seeing this reverse behavior in the graph. And here are our properties. Again, we are not going to transform the secant function, so we're not going to spend a lot of time on it. Okay, and the last one, of course, we are looking at tangent. The tangent and cotangent graphs both have asymptotes because, again, on the unit circle, there are values for which these are undefined because we end up dividing by 0 when we look at the ratio for tangent and cotangent. If you'll recall, the ratio for tangent is sine x over cosine x, and then of course for cotangent it's cosine x over sine x. So that's why we have these asymptotes here, and of course the behavior of the graph is different because tangent is a different ratio from sine and cosine. So again, we are not going to spend a lot of time on these properties. I just wanted you to have them for your notes because we are not going to transform the tangent function.